Hello, students. This is the last of the 5 ways to prove that triangles are congruent. And this one is only for right triangles, for this special case. So what do we see here? Oh, I already had that. I see a right triangle. Good. What other kind of way can we talk about this triangle? How do we know it's a right triangle? Yeah, because there's a box right here. There's a little square in the corner. That means that angle R is a right angle. That means the whole triangle is a right triangle. We could also say triangle RPQ is scalene, or is a scalene triangle. Scalene means all 3 sides are different. So these 2 sides are definitely different because they have different marks. This one we don't know about, but it doesn't look the same as this one, so it's probably different. We can assume that it's different if it's not marked the same as one of these 2. Right triangles are a little special. In fact, there's a whole study of math kind of based on right triangles in your geometry textbook. There's a whole chapter called right triangles. We'll get to that. Because of that, there's some special vocabulary. Instead of calling these sides, we have a different name for this. This one is the most special because it's the longest. It's also across from the right angle. So because it's across from the right angle, it means it's going to be the biggest side of this triangle because this is the biggest angle in the triangle. So does anyone remember this word? It starts with an H. It's Greek. Really long word. Yeah, this is the hypotenuse. That's a P right there. Hypotenuse. Okay, and then these 2, less special, instead of calling them sides, we call them legs. So that's a leg and that's a leg. So in this triangle, what was marked? There were 3 things that were marked. It's a right triangle. We have a right angle. And the abbreviation you'll see me use for this lesson is RT dot angle. That's a right angle. We have a right angle. And what else is given to us? There's a mark on the hypotenuse, and there's a mark on one of the legs. So this is called hypotenuse leg. Okay, now do you guys remember I talked about some other thing. If you said you have an angle and 2 sides marked, if you had an angle and a side and another side, okay, what does that spell? Ass. Okay, there is no ass property in this section. That is not allowed. You're not allowed to say that 2 triangles are congruent because they have an angle and 2 sides that match up. And in class, we talked about if I gave you guys 2 numbers, if you all had rulers and you created a triangle with maybe a 40-degree angle, and then I told you I want the 2 sides to be 5 and 6, and I want a 40-degree angle. And I said, go draw that triangle. Half of you would draw one triangle and half of you would draw a different triangle. And the triangles that you drew would not all be congruent. Therefore, angle side side is not a way to show that triangles are congruent. But if that angle is a right angle, then it's allowed. So instead of calling it the ASS property for right triangles, they call it hypotenuse leg. All right, so just remembering we do have another definition of congruent, and that is that you can get this one to map onto this one. So how could you get LMN to match up onto RPQ? And notice they're not in alphabetical order. That's kind of important that you get the order correct. So we're trying to get triangle LMN. We're going to do something to it. or two somethings to it. And then that's going to get it to map up onto RPQ. Okay, so there's lots of ways to do this. I'm going to take this point L and I'm going to translate it to where R is. So I'm just going to sketch what that would look like. It would look like this. The 2 would be here and the 1 would be here. Maybe it's a little bit longer. Okay. And this is my right angle here. And then, so what did I do? I did a translation and I moved it. I don't know how many I moved it because it's not on a coordinate plane, but I moved it so that L got to where R was. I don't know if that's exactly the right notation, but that's the idea. So L is going to move to R. Okay. And then how can I get this one onto this one? Do I need to rotate it? Do I need to reflect it? Yeah, I need to rotate it. I need to rotate it 180 degrees until this side that had 2 marks matches up on this side. Rotation, capital R or lowercase r? Good, lowercase r. Okay, and then for the rotation, we need to define 2 things. We need to define how far it's rotating and what is the point of rotation. And I'm going to call this point R because we're spinning the triangle around R. Okay, that's a way to prove that these 2 triangles are congruent. This one, I can get onto this one perfectly by doing this. I can move it and then I can rotate it. All right, here's the traditional kind of 2-column proof that we've been working on. And I've talked to a bunch of students and some of them are saying, oh, I don't get it. And I'm telling them, good. That means you're thinking and trying. Okay, if you get this right away, I'd be more worried. So these take practice. This is a whole different way for your brain to think. It is a very academic way to think. It is a very precise way to think. It's a way to think that we need more people in our society to be able to do. Okay, so first thing we do when we are trying this kind of deductive thinking is to stare at the picture. So what do we see? I see I'm trying to prove that LMN is congruent to RPQ. It looks like if I spun this around, it might actually be easier to do this problem. If I put R down here and P over here and Q up here, it might help me see it a little bit more. This is a rotation. I'm tired, you guys. Okay, how's that look? Not bad, not bad. Not bad at all. Okay, so LMN, RPQ, they're matched up really nicely. Sometimes it just, if you want to save your brain a little energy, you might want to rotate it so that they're kind of orientated next to each other. Sometimes that helps. So this proof works slightly different than the others, but it's still pretty straightforward. So step 1 is the figure is marked. And if I'm going to use hypotenuse leg, which I can use, the first thing I need to do is I need to show that there's right triangles. So that's actually going to be my first step. Angle L and angle R are right angles. Okay, that is given to me in the picture. They have the little box in the corner, so I know they're right angles. Okay, this next one is the one that's a little different. So notice I didn't say that they were congruent. Are they congruent? Yes. Do I need that in my proof? No. What I need this time is I need to say that triangle LMN, and triangle RPQ are right triangles. That's what I need to state in my proof. Is that given? Kind of. Yeah, but you also know that they're right triangles because of the definition of right triangle. Okay, so you could argue that one out. As long as, you know, the whole point of doing a proof is to convince someone who's being a pain in the butt. I don't agree with you. Yeah, well, that's what it means to be a right triangle because there's a right angle in the corner. Okay, let's continue. So I have pointed out that they're right triangles. Now I'm going to point out that their hypotenuses are the same. So the hypotenuse of triangle LMN is MN. That's the hypotenuse. So line segment MN. Does that match up? Does it have the same mark as line segment PQ? It does. Line segment MN matches up with line segment PQ. How do I know they're the same? Because they both had one little mark on them. Okay, almost done. This happened to be 5 steps. What else do I have to show? Okay, so I showed that a pair of hypotenuses were congruent. I knew they were hypotenuses because I had right triangles. Now, is there a pair of legs that are congruent? Sure. LM matches up with RP. If you're looking at this, the first 2 letters match the first 2 letters. So we write line segment LM is the same size and shape as line segment RP. Why? It's given to me. They have the same 2 little marks on them. And that's it. And then I write my answer. Triangle LMN is in fact the same size and shape as triangle RPQ. How do you know? How did you convince me? Because you showed me that we had right triangles, and you showed me that the hypotenuses were the same and the legs were the same. And this is the hypotenuse leg triangle theorem. Here were the hypotenuses that we showed the same, and here were the legs that we showed were the same. Okay, this one is a little more fun. We've got some more stuff going on here. We have a figure, and we're trying to prove the triangles are congruent. Less is marked here. So first thing we can do is stare at it. We can also mark our given information. I'm going to change colors. I think I'll use red for the given information. So line segment US, if I had more time, I might have written it out, is perpendicular to line segment TV. Line segment US is perpendicular to line segment TV. Do we remember what perpendicular means? Yeah, it makes a right angle with it. Okay, the symbol for perpendicular is this upside down T. Okay, when you see that in geometry, we say perpendicular. Okay, well that was kind of already marked because there's already a right angle there. What else is marked? Line segment TU, which is over here, is congruent to line segment VU. Okay, so I can put the same mark on here that I put on here. Okay, that's what this says. Line segment TU is, I have to write a little smaller, congruent to line segment VU. Okay. Wow, U's and V's, not so good. That's a U. Okay. And we're trying to prove that the triangles are congruent. And we are most likely going to use the thing that we're learning about right now, which is the hypotenuse leg theorem. So let's see if we can argue this one through. I'm going to start with this given information, because if I'm going to use hypotenuse leg, I need to convince people that we have some right triangles here. So line segment US is perpendicular to line segment TV. That was given. And then I'm going to say angle TUS, nope, TSU. TSU. Angle TSU. And angle VSU are right angles. It's an R. Fix it. Okay, that is not given. It doesn't say up here that they're right angles. It does say that this one's a right angle, but it doesn't say this one's a right angle. So again, this part you could kind of argue out a little bit. What I would use here is I would use definition of perpendicular. Because in the given writing, it said they were perpendicular, and we just stated that they were perpendicular. What follows from that, if they're perpendicular, then we know that they're right angles. Okay. If they're right angles, what kind of triangles are they? Right triangles. So I'm gonna do triangle T. I'm gonna change the order. TUS and triangle VUS are right triangles. What's an RT dot? Okay, how do I know that? That's the definition of right triangle. I showed you a triangle. I showed you the triangles have right angles in them. Therefore, they are right triangles. Definition of right triangles. Okay, I showed you the right triangles. Now what do I got to do? I have to show you that their hypotenuses line up and their legs line up, or one pair of legs line up. So which one's the hypotenuse in this? Here's the right angle. So across, this is the hypotenuse. This longest one is the hypotenuse. So are the hypotenuses congruent? Yes, they are. So line segment TU is congruent to line segment VU. That was also given to me in the problem. Okay, almost done. Uh-oh. Where's our leg? Is TS the same as SV? Maybe. Do you have a reason for that? Does it tell us that S is the midpoint? No. Could we possibly prove it? Yes, but I don't know how we would do that. Ah, what do we know about the two triangles? They share a side, right? What's it called? What's it called when the two triangles have the same part? How do we know that US is congruent to US? How do we know US is the same as US? Because it's the same freaking shape. So we can say line segment US is congruent to itself. You guys remember the reason for that? When you say, hey, something is the same on both, or something is equal to something, or that something is congruent to itself. It's called the reflexive property. Okay. Did I prove what I wanted to prove? Did I show that we have a pair of hypotenuses and a pair of legs that match up? I did. And did I point out to whoever's looking at this that there is in fact a right triangle? Yes. So we can write our answer. Triangle TSU, same size and shape as triangle VUS because of the hypotenuse leg triangle theorem. And here it is in your textbook. So that's why we used it. Notice one more time, it has to be a right triangle. So for this one, you only need these two pieces of information, but you also need that they're right triangles. And that is how you do that. Be good, work hard, keep learning.